So here we go. Maybe I'll just have the key in front here. I think the first part is quite self-explanatory. So there's 312 cell phone batteries, 11 are found defective. What is the experimental probability of finding a defective battery? So it's just 11 out of 312, right? We're talking defective. How many would be good batteries? What percentage? If I asked you that. 100% minus this, those are all good batteries, right? We just focus now on the defective batteries. But B is the right answer here. It's 3.53. See how I do the work here? This is the closest one. Which of the following is another way of expressing 7 out of 52? So a couple of ways you could have done this is divide this and get a decimal, right? And then divide all of these or wherever you have to and find a decimal. And 1/8 is actually 0.125. Or you just reduce this one. 7 goes into 7 once, goes into 56 8 times. So it's that. In 2,600 shipments, 70 of them have cracked tiles. What probability that the shipment will have cracked tiles? So it's 70 over 2,600. That gives you 2.69%, which is this one is the closest one to it. 1 mark for each, okay? Chocolate making team created 750 truffles for a wedding. 200 dark chocolate, and the rest were made with milk chocolate, right? What's the probability of picking a dark chocolate truffle, right? So 200 out of 750. If they ask for milk chocolate, right, they only tell you 200 dark, so you have to subtract it. So it would be 550, right? 550 over 750 if they had asked for the other one. So just keep that in mind. Keep going. Yeah.
Yeah, it was weird because my calculator kept giving 26. It wouldn't give me 26.
Oh.
Yeah.
That's something with your calculator setting then.
Yeah, I don't know, but the closest thing was 27.
So you just answered that?
Yeah. Well, like I did. Here, I'll do it right now.
Yeah. I can come and look at your calculator. Sometimes when you press a button, it rounds it for you. It just.
There's a bar at the end of it.
Oh, okay. So that means it's repeated. Yeah. Okay. So, so it's basically saying this, right? It just keeps on going.
Oh yeah.
That's what that bar means.
Okay.
Okay. Yeah, so it's assuming it's all 6s after. So you just have to assume, right, if you round to 4 decimals, right, this 6 will bump that to a 7. But in this case, you're fine because it's multiple choice. So not a big deal. What is happening here? A dog breeder has a litter of labs, right? Lab puppies, so cute. 23 puppies, 14 of them were chocolate colored and the rest yellow, right? What is the probability that the next puppy or the puppy in the litter will be yellow? I go 23 minus chocolate colored, so it's 9 over 23 here. I will say if you don't get the 9, it's -1, right? Because that's probability. Quite often I don't give half marks because you're given the total. Really, you just have to come up with a 9, right? So it's either 1 or nothing. And look at this one. 5/16 as a decimal percentage and words, right? So decimal, percentage, words. So I would say words. Let me see here. I would make this worth 1, and then these would be half and half. And if you did them all right, you don't have to worry about it. So this page is worth 7 marks. Got it? And the back side I might actually do with you. Oh, the first chart I can show you. Just cover the rest up for now. Right? So you turn that into a decimal, you turn that into percent and words, right? you didn't have to reduce, but if you have the decimal, it's 56 out of 100, 56%, or 56 out of 100. It's up to, that's what I need there. You don't need to have the reduced version there. And then this one here, you're starting with a percent, which is 0.29, right? Which is 29 over 100. And when I come with the words, I usually go by whatever I get on my fraction. So I'll show you how we're going to take marks off in a bit. And then this one, 10 out of 241, I go straight to here. Then I go here, then I go there. That's what I did. Okay. So I would say this, each row is worth a mark. If you have one mistake, you still get half a mark for that row. If you have more than one mistake in that row, then it's -1 for that row. Okay, so we're going to go one row at a time. Just make sure you have that right. And I told you this is going to come up quite often. Yeah.
So if I just put 1.4%,
yes. So listen to Dylan has a very good question. Technically, if you said 0.01 here, you are correct. But then you need to go back to your screen, multiply that number by 100, and round to 2 decimals again. So this should have been 1.44. Yeah.
Yeah, that's what I put 0.14. Where's 0.014?
Yeah, so I recommend if you do 4 decimals here, then you just multiply that by 100 to get this. You'll always get it right. So your decimal, technically, I cannot take marks off. But for this one, I would have to take half a mark off. Yeah. So complicated, yeah. Yeah. Just one half mark deduction today for rounding. So just put like an R next to every time you make a rounding mistake, and hopefully we shouldn't see too many R's, right? Unless you're a pirate, then not funny. Anyway, so there's a high school, and we have in that high school there's 968 students. A poll was taken of a random sample of students. That's very important. You want to randomize, distribute as much as possible. We're going to talk about that later on. You can't just ask a bunch of 12th graders. You have to ask some 12, some 11, right? It has to be all mixed up. Watch what I do here. What's the probability for a student to vote for Miriam? So I figure out the 106 here, right? This is the poll. This is the small sample. And there's 26 out of 106. So you only need the fraction, okay? You don't need the decimal percent. 26 out of 106 is good enough. So how many votes can Miriam expect in the election? Well, you take the probability of that happening, you multiply it by the bigger sample. So you can say either 237 or 238. Oh, you can't see that. Sorry. You can either have 237 or 238. It's up to you. Yeah. Oh, so it's like a lot of people. Because so you didn't, you just forgot to, you wrote it down like this? 26 over 106 or no? Just 26. But up here you have 26 out of 106? We'll go minus half today because you're in the right ballpark. Yeah.
For the first one there, I just put one of those. Like I reduced the fraction.
You reduced it?
Yeah, is that fine?
Yeah, absolutely. 23 over 53?
13.
Sorry, 13 over 53? Yeah.
So one of them is fine.
One of them is fine. There will be very few instances where I ask you to reduce. Only then you have to reduce to get the full marks. Okay. Yeah.
Should I just take half a mark off for B and C? I didn't put the solid number.
Oh, you didn't do this part?
No.
Yeah, just do just 1/2 mark here. Put an R here. That'll be also a rounding error. But don't take off more than 1/2 mark total today. Okay? Just 1 R.
Oh, okay. So I did not mistake on the page.
So you're done. Yeah. That's how the province marks. That's how we mark exams. As soon as you have one rounding mistake, we stop counting them. We still mark it, but what's the probability for a student to vote for Augustine? Yeah, right? Augustine has 20 in the poll, right? 20 out of 106 say that that's going to happen, right? So that's this is all you need, the 20 over 106. You don't need the other two formats. One more thing I want to say, if you listen carefully, if you got this wrong in A, but you're using that probability in B, you would get the full mark for B, right? Assuming that you multiplied and divided correctly. So you understand that, right? Like let's say you use 968 here, 26 out of 968. That's wrong, -1, but then we would honor it in B. You should know that already. That's how I mark, right? That's how the province actually wants us to mark. Because, right, it is what it is. So 7 marks for the backside. 7 and 7, that's 14.